Okay, so we are still working on this mobile application and we have already figured out quite a lot. Now, after activities and content providers, we want to have a look into the last component in this application, which is broadcast receiver. So we are only having two of them, where this one over here comes from some Google APIs where we do not want to have a look into. But this one over here, this has been developed or coded by the developer, and therefore there might be some flaws inside here. So let's see. It's being set to export a true, and we also got the Android name, the BroadCast. So if you want to trigger this, we need to apply this action name over here. But first of all, let's have a look what's happening inside here. Okay. As already mentioned in the broadcast receiver part, if you want to analyze broadcast receiver, the only thing we have to look for is the onReceive method. This is the only part that can be triggered by us right now. And in this case, we are only having this onReceive method, which is performing all the stuff, which is amazing because we have full control over this method and all those parameters. Once again, we've got intent get string extra. So we are having two strings inside here, which means we've got a phone number and a new pass. All right, this sounds interesting. So here we can see if the phone number is not equal null, so if we are having a phone number, we are triggering this part, this code. Otherwise, we simply just get out of this one. Okay, this means we have to provide a phone number. The phone number, it hasn't to be a certain value. No. The phone number is irrelevant, okay, interesting, but we do not care about this phone number right now. Okay, so we can trigger this broadcast receiver, and this is taking two values, a phone number and new pass, okay. And now let's see what's happening here. If we provide a phone number, no big deal, we can do this. Then we're going into the shared preferences settings, so we are getting those, okay. We're going into the shared preferences. This username base64 byte string, so we are getting this username in this field. Okay. Decrypt password, new crypto AES decrypt string, super secure password. Okay, we are fetching the decrypted password. So this part right now is going into the shared prefs and taking the username and also the password out into those two variables. Okay, let's see what happens next. Then we assign our phone number from here to here, which means this is now our phone number. And then we are having a message text, update password from, oh well. So here we can see this is the decrypted password which gets fetched from the shared preferences. So this is being returned back into this variable here. And this decrypted password is now being used in this message, text message, updated password from decrypted password. So this text message is doing something with the decrypted password, and it also claims that we are providing a new password, this one over here. Okay. And then, okay, now we are having the SMS manager, and the SMS manager is sending out this text message. Does it? System out print line for the change password. Okay, the ADB logcat is also being involved in this ridiculous function, but it doesn't print out any sensitive information beside what's the text phone number? What's this one? Okay, beside the phone number. Okay, and the text message. Wow. So within the ADB logcat, if we change the password is being printed out into the logcat because we have this directly here. The decrypted password will be assigned to the text message, or it will be included in the text message. And here this text message is being printed out to the logcat. So this one is leaking the password in the logcat output. Okay, this is something I haven't looked into, but realizing right now by looking at this. Okay, amazing. And then SMS manager send text. Okay, then we are sending the text messages which contains the old password. But wait a minute. All right, interesting. This is why you shouldn't rely on names that has been provided by the developer. Do you recognize something interesting in here right now? What happens with the new pass? I will give you a moment to think about this. Okay, so we have seen we can trigger this broadcast receiver and we can provide a phone number and a new password. The application takes the information out of the shared preferences, the old password, in this part over here. Shared preferences, then we've got this, where is it, get string. Get string, here encrypted username and password. The username, by the way, is also not encrypted. We have already figured out that's just base64. Do not rely on those schemes. Okay, so it's taking out this information and it's placing them, at least the password, into an ADB logcat output and also within a text message sent via SMS. Okay, but the new password is not being touched anywhere. This means the password never gets updated in this whole construct, and then we are returning out. So if we trigger this broadcast receiver, the update process via the broadcast receiver, we are not updating the password. We've gotten information leakage, which is absolutely ridiculous because we can fetch the original password, which is also pretty fine, because if we are not updating it, then the old password still works, but we are not updating the password. This one here is not being used anywhere, only here within a text message string, but not within another function. We have seen that the update process works. So after applying a new password and resetting this application, we have to enter the new password. But this has been separated from the broadcast receiver. Okay? So the broadcast receiver is simply just a heavily information leakage if we can trigger this on our own. We cannot update the password, but we are still fine with this one because we fetch the old password. But yeah, this is why we shouldn't rely on labels like this one over here, this new pass label over here. We are not setting a new password, at least not here. It's being done, but not in the broadcast receiver. Okay, nevertheless, let's trigger this broadcast receiver because I would like to spam the smartphone full of SMS. We are also sending a lot of text messages. This could be a finding in itself. So we are providing a phone number. Yes, we are providing a phone number where we send this message to. Okay, now I realize this. We can provide the attacker phone number and send us the old password for this application. Oh yes, okay. Now I know how this works. Oh yes, this would be a pretty nice finding. So let's do this over here. Okay. What do we need to get? Within the Android manifest, we need to have the name of this broadcast receiver. It's this one. Okay, so let's see. ADB shell. And then once again, the activity manager. And here we have something like broadcast. Where do we have it? Here we have it. Broadcast. So we can send it to a specific user ID to only one application, or we can send this broadcast to every user application. In our case right now, I mean, as an attacker, we are lazy. So therefore, we simply send it to all. And then those applications can react to this one. So you can receive an on-receive method regarding to this broadcast event. And then you can also react to this event. But yeah, this has been already defined in our application. We want to hack, therefore we're good to go. So yeah, that's all. We simply call broadcast. Default is, I guess, all. Yes, specified to send to all users, and then we have to apply our intents at the bottom. Let's do this. AM broadcast, then the package name, the component name. The component name is our package name. This one. And then let's see. I mean, I guess we do not have to provide a component name, to be honest, because this broadcast will be sent anyway to everything. But let's try this out both ways. I'm also not sure what's happening then. Okay, so we've got a component name, and then let's see. The name of this broadcast is this one over here. Okay. Okay, and now here we have to define the action. And the action is within the Android manifest. It's named the broadcast. Okay. Yes, the action should be enough because that's the action that gets sent out to every application out there, and then these application can react to this broadcast event. All right, but this doesn't hurt at all. But it also might work without having the package name. Okay, and now let's see, what do we have to provide? What intents do we need to deliver to this one? Intents, get string, we have a phone number and a new pass. Alrighty, so the phone number is in string. So we're using this one, extra key, string value. Okay, this is our string, and the value is, I guess we can add some quotes, but I guess this is also not required. So the phone number is, for example, 1337. Okay, that's the phone number of the attacker. I mean, the smartphone, I guess it's fetching all those SMS, even if it's not the original phone number. But yeah, it doesn't matter. And the other part was the new pass, which is not really relevant. Not relevant. To be sure that it is really not relevant, let's select an one which also fits those requirements, that we do not get trouble with this one. All right, this is how we can trigger this broadcast. And now let's see if this works out. So can I put the smartphone? I guess I cannot keep it in foreground. Unfortunately not, so therefore let's put this on the left. Okay, so let's see. 3, 2, 1. Okay. I cannot see something in here right now. This might be all old SMS. So let's see if there's some SMS message regarding to this one. Messages. Yes, here we have it. That's the phone number. Okay, that's the phone number. So this is confusing me a little bit. We have to look up what SMS manager sent text message, if this is the phone number where it comes from or where it should send to. So maybe let's look this up real quick. Okay, now we've got send text message, and here we have it. Okay. Yes, okay. The assumption was correct. The first one is the destination address. And if you're not sure, you shouldn't make guesses if there are official documentations out there. So you can simply look it up, and that's the source address. Nevertheless, the emulator is receiving all messages because it's an emulator and you might want to test certain things. So therefore, this message would have been occurred at the attacker phone. And now we can see the update for this user over here. The password has been updated from hacked at $123 to work at $123. And now we know we have changed this password to hacked via our activity manager. So yes, we have changed this password, which is ridiculous. Now we have another way to interact with those passwords. But in this case, it might not be updated. We can verify this because we know the user to this password is check. So we need to figure out if works at $123 is now working with the user check. So therefore, we first need to restart this application to be sure that those changes has been updated. And then let's see, check, and let's see if the old password simply works. Okay, there's no history, so the old password is hacked at $123. If this works, then the password has not been updated. Yes, that's correct, because I need to insert text. Oh, sorry, it's input text. $123. I'm also a little bit excited right now, so let's see. Yes, okay, as expected, the password does not get updated. This finding is an information leakage. It's a pretty nice information leakage because you can define the phone number of the attacker to send the current password of the last logged in user, which sounds amazing. And yeah, this is how we can abuse this. We have seen this broadcast receiver is leaking the password. So it's not updating the password, but it's a pretty heavily information leakage because we can send this to any number we want to have. Nevertheless, even if we are not sending an password inside here, sending an SMS via a broadcast receiver, absolutely ridiculous, because we could send any phishing SMS or other stuff to other people from this smartphone over here. There could be also costs, of course, which occurs on the user side. So this whole example over here, I find this pretty amazing. And yeah, it's a little bit constructed regarding to this stuff, but you will definitely find things like this out there. Not exactly like this, but closely. For example, once I had an application which triggered a really important event via a broadcast receiver. So this broadcast receiver could be triggered by a malicious application, and then this event did some crazy stuff where the developer didn't thought about that also other people can trigger this broadcast receiver. Broadcast receiver is always worth taking a look into. Alright, and this is how we can interact with them. Pretty easy, right? Okay, so that's all for those basic components. In the next video, we take a look into the crypto functionality. So we will have a look into those shared preferences and how we can easily decrypt this. And we will also try to hunt for hard-coded credentials, because this is something that can also occur, especially on IoT mobile applications. Alrighty? Okay, so I'm looking forward to see you in the next video.